HVAC 360 is brought to you today by the Emperor's New Clothing Company. Tired of face masks that are too hot, make it hard for you to be understood, and are simply horrified by the possibility of those unsightly tan lines? Well, we are proud to announce from the great looms at the Emperor's New Clothing Company comes the Midas Mask. This mask is made from our proprietary Invisalign fabric, which, for this product, we have coated with gold antimicrobial nanoparticles, which of course are 99.99% effective against killing all viral particles they come in contact with. Now you can breathe easy, communicate effortlessly, and tan like you live on the French Riviera. Well, actually, you probably already do. So, how much and where do you get these, you may ask? Whoa, pump those brakes, Daddy Warbucks. First, if you have to ask the price, you know you can't afford it. And then, because of the limited supply of this delicate fabric, we are rolling this offer out only to our existing clients. Quickly followed by all big box retailers nationwide. And to proactively address those one-star reviews we always seem to get, if you can't see the supple golden sheen from the Midas Mask, then you're probably slow, dim, and need to see your optometrist soon. That is to say, your eye doctor, you simpletons. Look for the Midas Mask today, or you'll never see what you're missing. Hey, welcome back. Matt Nelson here, your host for HVAC 360, helping you be the best and the brightest in the field of HVAC. I do all that by delivering curated content for you to consume your way, when you want it, because let's face it, we're all super busy out there, and the last thing we need to do is have to plan our day around another webinar or seminar. So let's get our learning on and let me dish out some relevant HVAC information, lessons learned, or maybe even a conversation with an industry expert. And if all this doesn't wet your whistle, you can always sign up for my weekly newsletter or subscribe to my YouTube channel. All right. So what is up for this week? This week, I thought I would share my thoughts and resources about the COVID-19 business. This is going to be a huge topic, so I'm going to whittle it down a little bit, and we're going to take it piece by piece. But first, I feel this is a proper place for some sort of disclaimer. I am not a COVID-19 expert, just like most people on the internet. I'm just sharing my opinion and some research that I've done. So don't think that what I'm saying is definitive by any means. Use this to start conversations and search out other subject matter experts for specific questions that you have on a go-forward basis. Having said that, the topics today we're going to be covering are primarily we're going to be talking about going back to work, but I want to touch briefly and talk a little bit about the stuff being built now and future designs. All right, so getting back into buildings. This is basically going to come from three different areas of research. First was the ASHRAE page. If you don't know, ASHRAE has put together a COVID-19 ASHRAE resource page, and it is very extensive. It's covering commercial buildings, healthcare, schools. There's a lot of good resources, and it is very detailed on kind of exactly what you want to do. The second kind of resource I'm going to use, and all these, just for your information, are going to be in the show notes. So go back to HVAC360.com/163. So the second document I wanted to cover was the AIA document. This is their Reoccupancy Assessment Tool version 1.0. That I had taken a look at. This had basically some big bullet points. Not a lot of detail in it, but it was very succinct and very well laid out. So kind of your yin and yang for this. The ASHRAE engineers really got into the nitty gritty of how to do things, and AIA kind of said, okay, these are the things that you need to do, but we're really not going to go into further detail about them. And then the third document that I'm going to just briefly touch on again, and this kind of echoes back to episode 151, where I talk with Dan Jones over at UV Resources. That was episode 151. And we're going to talk a little bit about UV again. So I'm going to start off with the reoccupancy assessment tool put out by AIA. So basically, some of the things, and this is kind of a bullet points, like I'm talking about. And so they broke it down into different systems. They talked about plumbing and they talked about HVAC, and those they talk about more than that. But this is kind of, I got to the meat and potatoes of what we're interested in. So I think the one interesting thing, and I didn't really think about this at the time, but, when we talk about kind of, everybody was like, okay, we're not going to be in our offices. We're not going to be in schools. All these buildings are kind of, all the commercial buildings are sitting dormant and they're not doing anything. Well, what's wrong with that? Hopefully everybody had the sense to kind of set things back because they weren't being used and occupied, and they weren't just kind of running them 24/7 like everybody was occupying them. That would save a little bit of money in that. But the plumbing, since everything wasn't being flushed, everything wasn't being used, there is a kind of need when we do reoccupy a building to kind of test the potable water system again, to make sure that Legionella isn't an issue when we go back to our buildings, because things have been sitting, because things have been stagnant. That tends to be one of the areas where Legionella tends to pop up. So that in and of itself is kind of the one plumbing thing that I'm going to throw in there. As far as HVAC goes, some of the bullet points they had was they wanted to increase ventilation and air changes. They wanted to create a negative pressure in buildings. Consider a maximum number of occupants for each HVAC zone. Change HVAC filters prior to reoccupancy. Clean ducts that have been dormant. Keep system running for longer hours, if possible, even 24 hours, 24/7. And then prioritize fresh air intake versus recycled air wherever possible. They want you to monitor humidity levels. They want to keep it between 40 and 60%. Disable the demand control ventilation. Consider using portable room air cleaners or HEPA filters. They want you to take a look at the UVC, and consider places where you can make it permanent. Consider places where you during non-occupied hours could use it more for a bulk sterilization. And obviously for larger buildings, checking cooling towers, that condensate for bacterial growth again. So let's talk about some of these things. Increasing the ventilation. And I have to say that when we got into the ASHRAE, what ASHRAE was talking about, they did talk about kind of, the bigger picture here. They talked about a lot of the details about increasing the ventilation, what that really means, how you can do that. Because it's not about just going ahead and increasing the ventilation. Your system may not be set up for that. You have existing buildings. You have existing buildings that are, set up and designed around a design day. So when you go ahead and change those things, increase the ventilation, you tend to create other problems. So that's where, when you go through a lot of the what ASHRAE had put out there, there's a lot of recommendations that, you need to hire an engineer. You need to hire a test and balance. You need to hire some commissioning. If you're going to make some of these things very effective, and you're going to do it in a safe way, and you're not going to kind of accidentally impact this, because you could, increase ventilation and air changes, but then you go down the list and you're trying to maintain, relative humidity at 40 to 60%. Maybe that's out the window. Maybe you can't do that any longer because that latent dehumidification that you get from most systems Most systems aren't actively dehumidifying air, so you get the passive dehumidification, and that's kind of out the window when you start increasing some of the outside air. Prioritizing fresh air intakes over recycled air. So those are some of the things. A lot of these things are not necessarily energy conscious. They're all focused on health. So that's one thing to kind of also dictate. So that was one of the things. Increase the air, air changes, increase the ventilation. And in general, there's some talk out there, and I've heard about do HVAC systems, spread the virus. Again, I am not a COVID expert. I would think that those people who run the finite element analysis are going to be a lot more in tune with what's happening and how HVAC kind of spreads, these kind of particles. But in general, if you think about it logically, HVAC systems, they're meant to kind of, churn the air. They want to have kind of an effective way of making sure that there's not dead zones in a room. You want to make sure that, they're washing the walls, making sure that, you don't get hot spots and things like that. So in general, that's what HVAC systems are supposed to do. So if you ask a system, your standard HVAC system not to do what it's designed to do, it can become a little bit, unrealistic, I would say. And two, I think when you think of areas that are specifically designed like that, like hospital ORs, those ORs have a specific layout, and they use laminar flow, and they know exactly where the airflow is getting to protect the patient on the operating table, to protect the people working on the patient, protect the doctors, the anesthesiologists, people like that, and the nurses. And that is very expensive. That is a very expensive thing to do. And I think that's kind of unrealistic to actually ask your HVAC system to kind of change the way it distributes. Not like they had, that was one of the things is, they didn't say, change the HVAC system, but whether or not HVAC is actually contributing to that, well, it's just something it does. All right, so obviously decreasing the number of occupants in a building, that's pretty much common sense. I think that's people are kind of at least thinking about, social distancing, keeping that 6 feet apart, making sure that, are people going to go to work on, one set on Monday and Wednesday, and the other people are going to go on Tuesday and Thursday. How is that going to work? Keeping your systems running for longer. So that would actually refer to being able to filter out and to kind of flush out a building when the occupants aren't in there. It doesn't have to do with surfaces per se, but it's just kind of making sure that all the air is kind of, it's churned over. And again, how effective that is, that's really to be determined. Cleaning the ducts that have been dormant. Again, if you basically shut off your building, are you going to go through and clean all your ductwork? That's probably not realistic. Probably not very realistic. Obviously, when we talk about prioritizing the fresh air intakes, that's a delicate balance like we've talked about with the humidity. The one thing that they were talking about, they wanted to create a negative air pressure. And I wanted to kind of address that specifically. Creating a negative air pressure in a building is something that you have to, in design, intentionally do. You don't want to accidentally do it. You don't want to do it on purpose without a lot of thought, because you are, in essence, really affecting your building enclosure. If you decide to just create a negative air pressure in your building without thinking about it, without getting the right people around the table and discussing this, you can cause harm. You can cause basically poor indoor air quality because you have like microbial growth in the walls. You start to get issues like that where you're not like typically during a a winter or a summer condition, you want to have it, you want to have it slightly positive. You want to be able to push the cooler, dry air out into the environment. And that way you're kind of protecting your building enclosure. And then in wintertime, you want to keep it neutral to slightly negative. And that way you're not actually, there's more moisture inside, so you're not driving that moisture into the cold walls. So you keep that balance and protect that building enclosure so you don't make that building enclosure sick by accident. So creating a negative air pressure, I don't think, I understand where they're going with that. And it might be something that, maybe in a vestibule, maybe in certain locations, but not as for a building as a whole. I don't think that would be a great thing. Disabling the demand control ventilation. Obviously, that is, an effort to save energy by reducing the amount of outside air that you don't need because the people aren't going to be there. And I think typically, if you go back to the limiting of the number of people that you have in a building, you're already going to be, if you don't have demand control ventilation, you're already going to be overventilating a space because of the way it was designed. So I think that needs to be factored in. And again, this is why you need engineers coming to the table to kind of think about all the systems in the building and reevaluating them. Consider the use of portable room air cleaners with HEPA filters. I think it's a great idea. That's one thing that you can do just to clean clean the air in the localized area. Again, where the occupants are, you can treat that. And then goes into the UVC, and I'm going to kind of gloss over the UVC a little bit because we're going to talk about that a little bit later. And then obviously it's a no-brainer for checking the cooling and water tower condensate for microbial growth. Yeah, those are some of the things that you want to do anyway. And ASHRAE, what ASHRAE did, obviously, like I said, it went into, what happens when you increase the filtration. What's the downstream effect? What are the effects to the system when you go from a MERV 6 to a MERV 8? There is something to be said there. And usually understand too, a lot of the filtration that happens at air handling units is to really protect the air handling unit, protect the equipment, increase the longevity of it. And when it's very critical to the space, then you have filtration that's closer to the space. You have, for instance, in the ORs, you'll have HEPA filtration at the diffusers. So that's something that, to protect everybody in the room, they're going to have HEPA filtration, to filter out, those super small particles, virus-sized particles out of the airstream. And that's why, getting a localized, HEPA filtration, you can just kind of recirculate the air in the room and just kind of clean it up that way. It's kind of like an air purifier, so to speak, except on a more effective level when you have that HEPA filtration doing that. And two, you got to realize, if this is something that they're going to be doing on a go-forward basis for a long period of time, for a number of months, if you're increasing the filtration, filters, it's no surprise to anybody in the industry that filtration and filters are one of the things that get pushed off on deferred maintenance. It's just an extra cost, and everybody's stressed out enough as it is, both work-wise and budget-wise, that replacing these more expensive filters, is going to have to factor into things. So, increasing the filtration, take it for what it's worth. Again, it needs to be evaluated on a case-by-case basis whether that's a really good option for you. And then again, a lot of things that are touched on in the the ASHRAE, these PDFs that are put out, You're talking about going through and making sure that all your building automation system, everything's working right. So it's basically kind of like a recommissioning, making sure everything's clean, making sure that you change the filters prior to reoccupancy, making sure that your energy recovery units, if you have those, are operating properly. Some changes that you might want to make. And again, this is one of those things where if you make a list of 10 changes to make your post-epidemic, post-pandemic response for your building, these are kind of very big changes that you're making to your building. Make sure you document those and make sure that it's going to be easy to kind of put those back whenever, if ever, we get back to a business as usual kind of mentality. All right, so getting back into let's talk a little bit about UVC, or UV, I guess, a little bit. And again, I'm going to link not only to the episode where we interviewed Dan, but he actually had an article recently in HPAC magazine, and I'm going to link to that, where he kind of went over a few things. Obviously, UVC is ultraviolet irradiation. It's going to be effective on surfaces. It's going to be effective for airborne bacteria. And I guess a couple of interesting things that I picked up on, in addition to when I talked to Dan, is there's really kind of UV, and you might ask, what is UVC? What happened to UVA, UVB? Well, it turns out that there's actually 4 different types of UV segments. So when you talk about UVC, that's a specific wavelength set. So there's UVA, there's a set for that. There's wavelengths for UVB and UVC. And then there's a 4th one, which is UV in a vacuum. So that's actually much smaller. But UVC is the very high energy and destructive type of UV. And again, these are kind of just lamps. So there are tubes that are kind of like, these long incandescent tubes that actually fluorescent tubes, not incandescent, but fluorescent tubes, like you'd see in old shop lights, except they have a kind of a clear coating in the middle, and they're a little different, but the form factor is the same. You have different lengths of these long tubes. So UVC is a specific wavelength, and they're very effective in germ killing because I guess UVC goes from 280 nanometers to 200, and right now I guess the magic number is 253. So that's right in the middle of there. 253.7 nanometers is really the waveform that's absorbed by the DNA and RNA, basically eliminating its ability to replicate. So it eventually, because he uses the term inactive, it renders the virus inactive, rather than quote unquote killing it, but it can't replicate anymore. So I guess for all intents and purposes, it is dead. But there's 3 ways that you can use UVC. One is going to be a way that you're going to utilize it in your upper room and air systems by interrupting the transmission of airborne infection diseases in high traffic and communal areas. And what this is basically, because the HVAC system, generally speaking, is good at churning the air. There's a portion of the air, especially when it comes out of the diffuser, it's going to hug the ceiling, kind of go down the walls, and then it's going to come back up. And you're going to have this circulation pattern, and a percentage of that is going to be, returned into the air handling unit. But if you irradiate the high part of the ceiling, that is kind of an effective way, they found, an effective way to affect the bacteria, the viruses, things that are kind of floating in the air. And it's very effective. Obviously, UVC, if you've ever been around it, it's this kind of this bluish light. But typically, you need to be able to shut it off to do maintenance on it. And I guess that's just one of the things, because if you don't, you essentially, it's just like if you do welding, you're going to be exposed to high energy UV, and you're going to get a sunburn basically. It's going to burn you, depending on how long and how much time you spend within being irradiated by the UV light. So just like it kills bacteria and bacteria and viruses, it's going to damage your skin as well. It's going to affect your cells. So make sure that the proper precautions and controls are in place when and if you add it. And that's why they did the upper levels. They also kind of recommended it too in the AIA tool, that there might be a way of setting these UV lights in an unoccupied space and kind of irradiating the surfaces when people aren't there. I've seen kind of like robots that do that, but also that was one of the recommendations, that you might have that as one of the things that you institute in your building on a go forward basis. A lot of things center around cleaning surfaces and things like that, but that was one of the ways to kind of affect that. The second way was to use Airstream disinfection systems. Now, I got to put a little caveat, because if you listen to 151, there is the time and intensity rule for UVC. So depending on what your feet per minute, depending on what your temperature, and just to kind of give you an idea, all these different factors play into how effective it is. You might have to use, for the higher velocities of airflow, you might have to use more tubes. That might be more expensive, more air draw, or more power draw, things like that. If you're doing it and it's a higher temperature, it's interesting to note that he says that the lamps that are at 55 degrees compared to lamps that are at 75 degrees, the warmer lamps actually produce 40% more UVC output than the colder lamps. So if you're if you're thinking about putting it in ductwork, if you're thinking about putting it in an air handling unit, understand that a cooler air temperature is going to derate the lamps. So not only that, and again, like we talked about on the podcast previously, is that you get about a year's worth of runtime out of these lamps before you change them. And then the third one was the coil irradiation systems within the air handler and duct runs. And again, I think that really is more for microbial growth and things like that are on the actual unit itself. Keeping it clean, keeping it biologically free of materials, but is that going to be the best solution for a COVID-19 situation? I don't know. My gut reaction, my feelings and opinion on that is it's going to be better for energy efficiency. It's going to be better. You're going to get some residual benefit of in that by putting it in units, but it's not going to be, if you're actually protecting the occupants, where occupants generally are. I don't think that's probably going to be the most effective way to use UVC. The one thing that he did finish off the article by pointing out is that there's been, this is not kind of a lot of smoke and mirrors. There's a lot of good hard evidence for using UVC in a lot of applications, and that is something that ASHRAE has a lot of experience with. And there's a number of different standards and that you can look at. It's in the applications handbook for ASHRAE. So very documented use of UVC lamps. But again, you got to be able to get the engineers in here, understand exactly what you're dealing with and what your best situation is, what's your best tact in handling the reoccupation of buildings. So and that's kind of where it is for getting back into buildings. When we talk about current designs, I have to think, are some of the current designs for buildings obsolete? You really have to think about it, because they've already they're being built and they're being put in, and they don't necessarily have maybe some of the diversity, because again, you need some sort of resiliency. You need to have some sort of like wiggle room, different ways that you can operate the system. And I think that's one of the things that designers in the future, when we look at future designs, that's going to be one of the things that future designers are going to need to plan for. What's the possibility of, the fact of, I think, way back when they were, talking about, different sort of attacks on buildings. And you'd have different plans and different scenarios, and the building would react to some sort of biological attack. This is really something that would be rare. That would be all government buildings, things like that. But this is something is very, very real, and it's going to happen now, as it's going to happen in the future. It's not a matter of if. This is just a matter of when it's going to happen. Is it going to be of this scale? Maybe not. Maybe not again in 100 years. But knowing that the last outbreak was of any sort of significant size was probably 10 years ago with some of the SARS that was going around. This has only been 10 years after that. So the likelihood of it happening again is pretty high. So future designs, you're going to have to have more flexibility. You're going to have to think about the filtration and the UV. You're going to have to do that going into it. Pressurization, building pressurization and the air changes. All these things are going to factor in to any sort of future designs. One last thing that I wanted to talk about briefly, because it was interesting. It popped up on my radar, was an article in the construction specifier talking about different products that are specified with antimicrobial coatings. And basically, it was a Perkins and Will, along with a Healthy Buildings Network. They produced a white paper in 2017 talking about these antimicrobial building products, and I think that it's really interesting. Because obviously, when we talk about cleaning, washing hands, being socially distant, you talk about surfaces and what we make surfaces out of. I mean, there was big deals about making things out of copper because it has certain microbial properties. But then there's this big push, and you've seen it before. Try to make things cleaner and more sanitary. You add this microbial coating, and I think that's one of the things that they kind of said that basically. Despite marketing claims suggesting otherwise, no scientific evidence demonstrates additional human health benefits from antimicrobial additives in building products and materials. In fact, if you think about it, antimicrobial additives have been shown to leach out of materials during use, entering drains and water treatment facilities. And in fact, certain antimicrobials, such as nanosilver, are considered toxic to humans and the aquatic ecosystem. Obviously, if you're going to have an antimicrobial surface, despite what it is, you're going to have to wash it. You're going to have to wash it, and those some of those particles are going to come off, and that's going to get into your ecosystem. Or even worse, you're going to think that, hey, it has this antimicrobial coating. I don't need to wash it, and it's perfectly fine. It's going to take care of itself. And that is just as bad, because nobody's really taking a look and governing these antimicrobial products. Be very, very careful about what you're specifying and what you're putting into your buildings, thinking that, hey, this might be more safe than another product, or just, making sure that, a better cleaning process may be better than spending money on antimicrobial products in and of itself. So, and again, this was just based on information from that white paper. I'm going to link to that in the show notes. All right, well, that's basically all I had for this week. Thanks so much for taking the time and listening. I hope this is helpful. I hope you've learned something. As always, the show notes can be found at hvac360.com/163. If you know somebody who might be looking to step up their HVAC game, consider sharing this episode or another one of your favorites with them. This is really by far the best thing that you can do to help out and spread the word about this podcast, and I'd really appreciate it. If you want, subscribe over to hvac360.com for a weekly dose of our written word, or browse my YouTube channel. Right now, it just basically has the shows, the podcast episodes, but I'm hoping in the future that I'm going to add some other material on there as well. So, lastly, if I'd be greatly honored if you'd leave me a rating and review over on Apple Podcasts, because that still really affects the, who's able to see this, who's able to find it, and I would really greatly appreciate that. Well, that's a wrap for this week of HVAC 360. I'm Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.